Hey, Algebra 2. Today we're going to work on some story problems involving quadratics. The two main things are when will it land or what is its maximum height? So last week we talked and the x-axis is the time and the y-axis is going to be your height. So we have 0 down here, and for sake of argument, maybe it goes up to 100. And so the height of the ground is always 0. And so if it starts on the ground, it goes up and it goes back down. And so when will it land, you're trying to find that time right there. So in this case, when you're trying to find out when will it land, you're finding x-intercepts. And when you want to find an x-intercept, you're going to set y equal to 0. The quadratic formula will always work. You could also make a table of values, you could factor, but quadratic formula will always get the job done as well. X equals negative b plus or minus square root b squared minus 4ac all over 2a. The maximum height is what we did last week. So we want to find when is it at the top usually. So your x-axis is still your time. So you're going to have to find your axis of symmetry first. And then you're going to have to take that and you're going to have to plug it in to figure out how high it got. All right, let's read through some of these and see which kind of problems are they. A ball is shot from a cannon into the air with an upward velocity of 40 feet per second. The equation that gives the height of the ball at any time is this. Find the maximum height. Maximum height is what we talked about last week. That is a vertex kind of problem. So when we do the first part, you're going to find your axis of symmetry, which is the x part of your vertex. We're going to use negative b over 2a. So there's my a, there's my b, and there's my c. So the numerator is negative 40 over 2 times negative 16. Negative 40 divided by negative 32. I'm going to use decimals today. So it took 1.25 seconds for it to reach its maximum height. But we have to find what that height was. So plug 1.25 in right there. Negative 16 times 1.25 squared plus 40 times 1.25 plus 1.5. I put that in the calculator earlier and I got 26.5 feet. That is the maximum height attained by the ball. Number 2. A ball is shot from a cannon into the air with an upward velocity of 40 feet per second. That 40 feet per second, that's already taken into account right there. You don't have to try to reuse that. Here's the equation. How long did it take? So we're going to have to solve for t to reach the ground. You have to remember the height of the ground is always 0. So in place of that h of t right there, I'm going to plug 0 in. So if you have to solve for t, and I don't know if that's going to factor, but I definitely don't deal with decimals. So I would label my A, B, and C, and I would run the quadratic formula. So the quadratic formula, we already wrote it down. It's up at the top there. So the opposite of B, so I have negative 40 plus or minus B squared minus 4 times A times C all over 2A. So I get negative 40 plus or minus radical 1696 over negative 32. All right, so I would go through and I'm going to use the plus first. So into your calculator, go negative 40 plus radical 1696, and then hit the enter key. And then go divided by negative 32, enter. I'm looking for my answer sheet. The one with the plus, I'm getting 2.54. And then I'm going to go through and I'm going to use the minus sign. Negative 40 minus radical 1696. Hit enter. Divided by negative 32. Enter. And I got hey, you know what? I'm looking at my notes backwards. Sorry, that plus looks like it's negative 0.06. And the second one is actually where I got my 2.54. So it took 2.54 seconds for the ball to hit the ground. So when it says, when did it reach the ground, set your equation equal to 0 and solve. Anytime that you get a negative answer, you're going to have to disregard that. It is not reasonable that it took negative time for the ball to land. Number 3, a ball is shot from a cannon into the air. Here's my equation. How long does it take the ball to reach a height of 20 feet? Okay. Well, this h of t, that's your height right there. And so it's telling you, why don't you figure out what happens when h equals 20? So back a long time ago, we said that we only know how to solve quadratics that are set equal to 0. So the first thing I would do is I would subtract 20 from both sides. And that is negative 18.5. So there's my A, my B, and my C. So your x, or t in this case, is negative b plus or minus the square root, b squared minus 4, a is negative 16, c is negative 18.5, all over 2 times negative 16. So I get negative 40 plus or minus radical 416 over negative 32. All right, so I'm going to go negative 40 plus radical 416. equals, divided by negative 32 equals, when I do the plus, I get about 0.61. And when I use the minus, so in my calculator, I went negative 40 minus radical 416 equals, divided by negative 32 equals, and I got 1.89. And these are seconds. So I got two good answers. Is that reasonable? Does that make sense? Sure. All right, so it starts up here at 1.5 feet up. The ball goes up and it comes back down. It wants to know, so I just did this problem earlier, and it hit a maximum height of, so like right here is the 26.5. And it wants to know when it's going to hit 20 feet. So if you kind of draw a line over, so it crosses your graph in two places. So it's going to hit the first time at 0.61 on the way up, and it's going to hit a second time at 1.89 seconds on the way down. And then we just solved it earlier. So back in step 2, it said, how long did it take to reach the ground? So we got 2.54 seconds. And so it took 2.54 seconds for it to land. So that's what your entire graph and situation looks like. We'll do some more of these in class.